When I moved into this new office space, the place had a few of these old Hikvision security cameras. It also had this junky old Hikvision NVR, or network video recorder. You plug the cameras right into the back and it gives power to each camera, records all their feeds to a hard drive, and lets you access it remotely. Now, don't get me wrong, if you just need to store security footage, this thing's fine. But this is 2024. AI is taking over everything, and not all of that is hype. Can it help us make a better NVR? I'm going to take this Raspberry Pi and plug in this TPU that runs machine learning models. It'll help the Pi identify people, cars, bikes, or, well, anything. I'm going to feed all the old cameras into it and build a modern, free, and open source NVR that's actually better than most of the commercial ones. I'm going to literally spy with my little Pi. I guess on myself though, since the cameras will be around my office. But there are a few things I need to do to get this all working. I have to reinstall the cameras because I had to take them all down for construction. I have to get PoE power to each camera using a power over Ethernet switch. And I have to set up Frigate on a Raspberry Pi. Now, you don't actually need a Raspberry Pi. You can run Frigate on most any computer. It just has to be able to run a Docker container. And if you use a newer Intel CPU or even an ARM Rockchip CPU, Frigate can use its internal NPU. But I'm using a Raspberry Pi for this build. Using it with the Coral TPU, it's efficient and plenty fast, at least for 4 or 5 cameras. But one big advantage of commercial NVRs though is you can get them in a desktop enclosure like this, or even in fancy rack mount boxes like the Ubiquiti network video recorder. There's nothing like that for the Pi, is there? Is there? This is the Axzez Interceptor 1U case. Axzez sent this to me like a year ago, and they didn't even ask me to make a video about it or anything, but I did get it for free, full disclosure. But it's a $130 rack mount enclosure that holds their Interceptor board and accepts an add-on PoE board and 3 hard drives. You can build your own open source rack mount NVR with this thing. My goal is to take this box, make it almost silent with some Noctua fans, and get Frigate running on it. The coolest thing about this box is Axzez makes this PoE board. It has an internal power over Ethernet switch, so you truly get everything self-contained in one box. That means I won't even need an extra PoE switch. I can just plug the cameras straight into here. At least that's my hope. Now, before I start building this out, I want to make it clear, even with a Raspberry Pi, you don't need an elaborate box like this to get started with Frigate. In fact, at home, I've been running Frigate for months with 2 4K cameras and a Pi 5 with an NVMe hat. And I also did a lot of testing with Frigate on this BitPyRat, a tiny Compute Module 4-based board. Frigate runs great on any Pi 4 or 5, and you can even use Coral TPUs directly with a PCI Express bus on the Pi 5. But if you want an all-in-one solution where you can just build it yourself and still look just as good as any Pro NVR, this thing is as good as it gets. Let's open up the case and get started. These are not hot swap, but they aren't too hard either. I'm going to call an audible. Instead of installing all 3 of these hard drives, I think I'll just do 2 in RAID 1. And it looks like you just put the screws in on the sides. Not necessarily the simplest solution in the world, but it works. It's okay. The other part of this that's important to get right is the power. So this is it takes a 12 volt input and gives a 48 volt output, 5 amps maximum for this PoE board. And this is what takes the power supply power at 12 volts and outputs it at a PoE rated 48 volts so that you can power devices off of here. And this is not necessarily the best solution for this, but it is a solution and it should work. This will go up here. These guys, it's getting kind of tight in here already, but this is a compact case, so I can't fault them too much for that. This is our power supply, and this is Flex ATX. This is a 350 watt. This is what they sent. You can use other power supplies with the Interceptor board. The nice thing is it uses standard 24-pin ATX, and your hard drives use standard SATA power connections. So as long as we get this installed and it fits in here nicely, it's not going to be an issue either way. It seems like you'd want these exhausting, not pulling in air. But who am I to say? I'm going to go ahead and do the same thing that they're doing, use these as intakes. So the fans are definitely not hot swappable, but not too hard to replace one. You do have to take down the system to do it. And you, my friend, can go in the back. Or there. Much better. now I can start getting this power connected here. Well, now it's time for this guy. This has 8 ports, PoE ports, that go into the switch with an RTL 8367RB. And it's a managed switch. I think it's 100 megabits. I think you can get a gigabit to the Pi and then 100 megabits to all of the PoE devices, which is fine for PoE cameras. This is a little short. I'm gonna have to figure that out. And I'm gonna figure out the rest of this wiring and figure out how to get this power connector over here, and I'll rejoin you in a minute. Did you ever record an entire video and then realize your recorder was in the wrong setting, and so you have a bunch of wasted footage? That's exactly what happened while I was building this. So you get to skip that part. I might add a few highlights before this, but anyway, I'll get to the pertinent details. One thing is this particular unit, this is one that I got a long time ago for their old extended case, and these leads were kind of short. So I don't know if that's the case. If you buy the latest one that they have, they might have ones with longer leads on it that get out here, but I could not mount this over here where it's supposed to go and get these yellow and black wires all the way to the PoE board right here. A couple other interesting things. The power supply, the bracket, I had to bend it a little bit with at least this power supply. It's a 350 watt power supply, Flex ATX. And, you know, but it fits fine. These are all little things with a case. This is, I think, their second design of this case. So over time, they'll figure out little tweaks to make it a little bit better. I'll zip tie this a little bit, maybe, probably not. But there's a cabling mess here that there was just no space with a third hard drive bay. And the one downside is there's a little gap on the tops and bottoms of these drives, so some airflow will get through. But I don't know if, even with these two fans, I'm not sure if that's enough to really push air through the system. And it's a strange setup. It'd be nice to have a couple intakes up here pushing the air back, and then it would exhaust out here or exhaust out the back, but that's not how this is set up. But I have the fans routed over here. I had to use the fan extension cables to get them to the Interceptor board. I plugged the Raspberry Pi in here. It doesn't have a micro SD card slot, so I wound up using eMMC, a Compute Module 4 with eMMC, and I don't need Wi-Fi because this is going to be in a fully enclosed metal box, no external antenna or anything. And then I put a little CR2032 battery in for the RTC so it can keep time. And here's the front panel header connections. There's a power switch and LED. And then there's the USB 2.0 ports to the front panel that plug in back here. And there's probably enough airflow that things will stay cool. But let's get the lid on this thing, wherever I put it. And I'm gonna see if it boots up. I already flashed Raspberry Pi OS onto the Pi inside of here. So Raspberry Pi OS 64-bit Lite, and I have a script that will install Frigate. Now, one thing I don't know is exactly how the network switch chip works in here. I think it's configured to just like pass through the networking and be just a basic switch, but if it's not, I might need to do some things to get the switch working with these ports. But let's screw this in and we'll get it turned on and see what happens. Fingers crossed. It seems like they have a different screw for the sides of this than they do the back, which is an interesting design. It's an interesting I can't say that. Design decision to have. It has coarser threads on the side and a longer thread on the back. But you know, it all works in the end, hopefully. Let's get this, it's a little bit heavier now. Let's get it plugged in and see what happens. I'm gonna plug the power supply in and hopefully it does not kill me. This is an all metal chassis. I hear the hard drive spinning up. The fans are going. The power supply fan is actually very quiet on here. That's an unexpected surprise. But this system actually boots up right away when you plug it in. The power button only works after the first boot. So I'm going to let it boot up. I'm going to plug in networking and see if I can get to this on my network. Okay, I called this Pi-NVR, so I'm going to try ping Pi-NVR.local. And I'm not seeing it. Nope, there it is. Okay. So it's .221. I'm going to try to SSH into it. SSH pi at pi-nvr.local. Okay, we're on Linux 6.6.20, and I'll see if we can see the PCI bus. ls PCI, there it is. We have the SATA controller. I think it's a JMB 585, and we'll see if we can see the hard drives. ls blk. And there they are, SDA and SDB, both of them are 8 terabytes. So I was reading the FAQs on Axzez's website, and it does mention that there's a few bootloader settings it wants us to change, which I'll have to do somehow to that eMMC on the Compute Module 4 on the bootloader. The other thing is, it says if you use your own OS image, so I'm using Raspberry Pi OS, I'll need a kernel patch, and maybe this if, I don't know if it's using, I think we're using mainline Linux DSA, but I might need a kernel patch if I want to control the onboard networking. I don't know if it'll work without it. If it still works, I might not worry about this for now, but if you want to control that onboard switch, then you probably need this patch. I don't think I need to add some of those options to the bootloader because I just shut it down and I pressed the power button and it turned back on and booted up fine. So I guess you don't need to make those bootloader changes. So that's nice. So it's day 2 for this project. It was getting late yesterday and I went home and I'm back now. And we're gonna get this thing going. You can see that it sees the USB device. It's called Global Unichip Corp. I think it used to be Google Incorporated, so I don't know why the vendor has changed on the Google Coral. But I plugged that into the box. And it's USB 2.0, so you can see it's 480 megabits. But that should be okay for inference, especially for just a few cameras. But we'll test that and make sure. But now that I have the box running, I have 2 hard drives, I need to get Frigate running on here. So what I use is Pi-NVR, a project that I built that I've been testing on a few different computers lately. But this project sets up different NVR systems on a Raspberry Pi in this case. And I've tested ZoneMinder, Shinobi, and Frigate, and the other 2 are just they're not very fun to use. Shinobi in particular was so complicated to get running that I decided just to stop trying it, and now I'm using Frigate for all of my NVRs. And this repository has instructions for getting going and some recommendations for cameras and Raspberry Pi models and all that, and an installation guide. So we're going to follow that, and I'm going to go over to my project folder. And I already set up this config file with one of the cameras. This is the Hikvision dome camera I have. It's a, it's 1080p, the exact model number. I might put it on the screen or something. But these are the settings for it in Frigate. Now, how do you figure this stuff out? Because this is the one part of Frigate that's kind of annoying, is it's all YAML. And I'm very familiar with YAML because I use Ansible a lot. For example, this playbook itself is all YAML that describes how to install Frigate on the Raspberry Pi. You have to, basically, I've found, go to the Frigate documentation, go to the Frigate GitHub, and search around for your particular camera. The thing is, I would recommend sticking to cameras that other people have used. Don't just go out and buy the cheapest camera or buy some camera that you think might be amazing. Buy one that other people have used, unless you're good at figuring out where the stream paths are and things like that. Because some cameras are better than others at giving stream outputs that can be taken into Frigate easily. And I also have some Anki 4K cameras that are also very easy to integrate. And the key is, this is after I've done a lot of testing with a lot of cameras, is when you do the detection, so when you're detecting whether there's motion or whether there's a person or a bike or a car or something, you want to use a substream from the camera. So cameras actually send out a full resolution stream and one or more substreams that might be like 480p or even lower resolution. And if you use that full, like if you have a 4K camera, then your Raspberry Pi is going to be processing 4K video real time, which really bogs things down for motion detection. I'm going to go ahead and get Frigate installed on here using this Ansible playbook. It basically runs a Docker container on the Raspberry Pi with Frigate. Anyway, I have Ansible installed. The inventory.ini file, I need to change this to pi-nvr.local. Ansible user is pi. And then the config file should be all correct here. And I have it set to use the Edge TPU on USB. And then now I can run Ansible playbook main.yaml. So this playbook will install Docker on the Raspberry Pi, and that's a prerequisite to installing Frigate. And then the next playbook I'll run will install Frigate using Docker. Okay, so now Docker's installed. I'm going to see if I can log in and Docker PS. Okay, so Docker is running, and now I can go back out. And one other thing that I need to do before I install Frigate, I believe I have Frigate configured to store things in /mnt/Frigate. So I need to set up storage at that path, or I could change this path to somewhere else. But since I have these two hard drives that are 8 terabytes, I want to set them up in a RAID 1 array, and that will let me have 2 hard drives that are both 8 terabytes basically mirror each other at all times. So if one hard drive fails, I'll still have all the data on the other hard drive. It depends on how important that footage is to you to have persistent. And of course, just having it in RAID, even if it's mirrored, doesn't mean it's backed up. So if you are really wanting that footage, you should also have this thing back up to another device like a NAS on your network. But I do want to put these 2 disks into RAID, and I have a guide for that on jeffgeerling.com, RAID, how to guide without ads. Let's get our information about it. So it looks like it's there. It's going to do a resync. That takes a while. You can still use it while it's doing this, but it will take a while, and you could monitor that if you want. And I can actually hear the hard drives over there. They're not actually in a vibration mount or anything. They're just mounted to the metal. So that is one concern. Some hard drives can handle that better than others. If you get a NAS, or they make actually special hard drives for surveillance or for NVRs, those generally can handle the vibration a little bit better than like a desktop hard drive. So get the right hard drive for the thing that you're going to do with it. The formatting is complete, so now I have a formatted RAID volume, but I need to mount it. So if I say lsblk, I can see I have MD0, which is an 8 terabyte RAID 1 array. And here it is. So I have 8 terabytes there. So let's make sure that the RAID actually comes back up after a reboot, because that would be very sad if we did all that work making a nice little RAID 1 array and it doesn't show up next time you reboot and Frigate starts writing files to the local file system. So let's see. I just logged back in, and we have, it's now MD127. I don't know why it does that. It was MD0 when I created it, but now it's 127. I'm sure there's a reason for that, but it is mounted at mount/Frigate. I'll follow the directions here to run Frigate/main.yaml, and this will set up Frigate for me. While that's setting up, I actually did plug in one of my cameras. I have it set up as cam01.gearly.net. It is another of these Hikvision cameras that came with the Office Space, and I have it plugged in right now through a little power over Ethernet adapter. You plug that into the wall, and then you plug the network into it, and then the camera into its PoE jack, and it provides the power. But like I said, I should be able to plug this straight into the back of the box, but I'm not 100% sure if that networking setup will work yet with Raspberry Pi OS out of the box. So we'll test that later. Okay, so if I log in, let's check if the Docker container's running. I'll say Docker PS, and it looks like it's been running, and it says it's healthy. And if I go over to Pi-NVR.local, what port are we running on? 5000. If I go here, I should see Frigate, which I am seeing it come up. Let's see what happens. There it is. So this is Frigate's main interface, and forgive the camera being upside down. I don't have a mount for it, and this is not mounted yet in the studio, but this is camera 01. The dashboard kind of gives you an overview of all your cameras and a snapshot from when you load the page. So if I refresh this, you'll see that the timestamp here updates. And yes, it's a little bit off. I need to set the time and date for this camera. But it has, for each camera, events, recordings, and then some toggles. You can turn on and off motion detection, which also turns on and off the object detection based on the motion. You can turn on and off recording 24/7. I have it configured right now to be recording all day long. But if I go to events, I've moved in front of the camera and I waved my hand in the camera, and it already detected those. So it saves those, and you can have this trigger sending them out to Home Assistant, which is what most people do with Frigate. Or you can do other things with these too. It publishes a feed using Mosquito, MQTT. and then you can do with that what you want. If you click on it, it just gives you the clip with a little bit of padding before and after. And here you can see me walking by, and then I come up to it, and there I am. So it gives you, I don't know, it looks like maybe 15 seconds before, 15 after. And this player is also nice. It lets you play back in faster speeds and slower speeds if you want. And here's one where I think I just waved my hand. It's a good little player for in the browser. I actually use this a lot at home. When I hear something outside, I can just go in, pop in, find the event, and then go to it. The other option is you can go to recordings, and that just gives you all the recordings, and as time goes on, this will go 9 o'clock, 10 o'clock, 11 o'clock, etc. And you just click on the hour, and then it'll also give you a breakdown of events detected that hour, or you can just go to the hour and then hide this, and you can scrub through all the footage from that hour. So you can see all the different things that go on. The other option is, in addition to going to events and clicking download to grab one, you can go to exports, and you can pick any camera, and you can choose a time range, and you can either export the full video in real time, or you can export a time lapse, which is really cool. If you have a camera set up outside and you want to see like sunset and have it sped up, you can just grab a time lapse of it. The other things that Frigate gives you out of the box is a little page showing you your storage on your device, how much space you have left, how much is used up, and that'll help you to figure out, especially the stream bandwidth. It'll help you figure out how much storage you might need. So in my case, with one camera, it's saying 400 megabytes per hour. It also gives you an overview of your whole system. So it's showing me that I'm using a Coral TPU for a detector, and it doesn't use much CPU, it doesn't use much memory, and it takes about 35 milliseconds to take one frame that has motion in it and detect whether there's an object in it. That can actually get a little bit faster if you use USB 3 or PCI Express on the Pi 5. But this is plenty fast. It's faster than using the CPU on the Raspberry Pi by quite a bit. And then each camera, it shows you stats for it, how much CPU that camera is using for the stream, and how much it's using to capture footage, and how much it's using to detect motion in it. So this is a good way to see, like, is my computer fast enough for the types of cameras and the number of cameras that I have? And in this case, with these stats, you could probably get 4 to 6 cameras at 1080p on a Compute Module 4 with no issue at all. It'll show you the full configuration. This is basically the same configuration that I just showed you from the Ansible playbook, and then some logs. And you can see that right now it's having trouble publishing the Mosquito feed. That's because I haven't configured that all the way yet. The next step here is to get one of these cameras installed in the space and start actually recording real footage and using it as an NVR for the space. I'm actually going to cover camera installs in my next moving vlog, so subscribe for that. And there are a few things I didn't cover here that are really useful features in Frigate, like masking camera feeds to exclude areas from motion detection. But for this video, I'm overall pretty happy with this Axzez box. And I love that I can build my own open source NVR using a Raspberry Pi, and it looks pretty good. Could I get more camera feeds or faster object detection with other hardware? Sure. But the Raspberry Pi has great support, it's efficient, Frigate runs just fine even on my older Compute module, and it's been really stable in my testing. Check out the links in the description for more, and also my blog posts with guides for resetting these older Hikvision cameras and optimizing Frigate performance. Until next time, I'm Jeff Geerling.